Good afternoon. Welcome to the Startup Showcase. Sometimes we call it the pitch session for the electricity and the grid. And we did that for the last year. And we have a lot of things available. Please come forward to the round table and can be more engaged with our founders. And we had a wonderful session last year. And I really wish that we will continue the success we built for last year. But as we all know that we are facing completely different dynamics this year. And we have headwinds, but also have tailwinds for this clean energy transition. Let me just mention a few of them. After nearly almost 3 decades flat of demand growth, and we are seeing one of the best opportunities in the last 3, almost 4 decades in terms of electricity demand growth. Very likely, based on different projections, the electricity demand in the United States will increase by 25% in the next 10 years. This demand growth will introduce tremendous opportunity in terms of deploying new, hopeless clean generation technology, but also deploy more transmission and distribution technology. In the meantime, we'll be more engaged with customers. But in the meantime, we're also facing a lot of challenges. Just mention a few of them. The first one is resilience. Now, compared to 1990s, the average duration of outage is almost doubled because of extreme events, because of the aging infrastructure, etc. And the second, affordability. Very fortunately, because of the natural gas, the electricity price in the United States is relatively flat. But in some region of the countries, the electricity price increased tremendously. How we make sure that we can have affordable and clean electricity for this energy transition is very important. Last but not least is really the infrastructure. It's just so hard to build new transmission line in this country. When I started my career about 20 years ago, worked at the Electrical Power Research Institute, working very closely with NERC. The number I have been hearing 20 years ago, average it takes about 7 years to permitting and building new transmission line. Now, you will hear some of the numbers from the startups will teach us that how long would take to build new transmission line in this country. And with that, to help accelerate this energy transition, we need innovations. We need collaborations. You will hear all of them today in the next 80 minutes. First, let me welcome a very good ecosystem player, Schneider Venture Accelerator. Gregor are going to share with us because we need the money for sure, but more importantly is we need the ecosystem be able to offer project opportunities, enable the startup move to the next stage.
Thanks a lot, Meng. Really appreciate the invitation. Nice to meet you all, some old faces, new faces, because as you were mentioning, that's definitely an ecosystem that is really at stake. And with SE Ventures, our mission is to drive a decarbonized industry. So my name is Grégoire Viasnov, and I lead our accelerator program at SE Ventures. So SE Ventures, as you were introducing, is an independent platform, independent fund, really structured as you would expect by any financial VC, but backed by Schneider Electric as our single LP. So we take the most of the two worlds. Our investment committee is completely a standalone investment committee. And in 60% of the cases, our portfolio companies have been able to set a partnership with Schneider Electric, which has been named the most sustainable company in the world a couple of times over the past years. So we have a lot to learn all together. And this platform is absolutely stage agnostic. So we start with pre-seed, or even sometimes before the company is even incorporated, up to the later stage, which materializes in terms of check size from few hundred K to 50 million. So that positions us in a very unique manner because we are able, which is not mandatory, but anyway, we are always able to start super early, bring this market knowledge, and do our pro rata and follow-up up to the later stage. We have a couple of unicorns across the different geographies. In the US, 3 to 4, like Together AI, like AI Dash, like also Augury, for example, but also in Europe, like Vercor, who raised 3 billion a few months ago. So we are really industrializing this model, also with a new accelerator that we have launched now a few 6 weeks ago. We have already received 400 applications in a few days, highly demonstrating the healthy ecosystem which is about. A lot of people are willing to bring this innovation at scale and looking also how you bring capital and market knowledge, because industry is a relatively complicated ecosystem from utilities to homeowners, how you can really take the most of this different value chain and scale fast is requiring a pretty deep knowledge. So this is exactly what the platform is bringing for early stage founders and up to their later stage growth. Happy to be with you today and to answer to some of your questions if you have during the session or right after.
Thank you very much. And also, let's now start our, he's going to hang around here. Feel free to ask any questions. If you're a startup company, you'd like to have we have a lot of venture capital company here. You need money, you can ask all around. But if you're looking for the project opportunities, feel free to talk to Guagua as well. So now let's move on and go to the showcase and also the pitch session. And we like to use the word showcase because pitch sounds like we compete with each other, but this company is just so good. Everybody should win the pitch. So we just change the name to be the showcase. And without further ado, let's get started with the first company, Magnefy. Joseph?
Hi, good afternoon. My name is Joseph Cao. I'm the co-founder and CEO of Magnefy. Our mission is to safeguard tomorrow's power with AI and magnetic sensing. Imagine yourself stuck in London Heathrow Airport for a day because of a nearby transformer fire. It sounds like a movie's plot, but it literally happened a few weeks ago. And you are going to see this more and more often due to the aging infrastructure and the accelerated electrification, especially in mission-critical facilities like data centers, hospital, and the manufacturing sectors. And the fact is that this is becoming a more and more important and even urgent problem because more than 40 million of the transformers in the US are reaching the end of life and are failing in the US. And it's not just a pain experienced by the end users, but also the manufacturers that provide the warranty and also the insurance companies, because every major failures can cost tens of millions of dollars, and it takes more than a year and twice the cost to replace the transformer because of the supply chain challenges. So many stakeholders in the value chain are seeking accurate yet affordable predictive maintenance solutions for transformer monitoring. But the challenge here is that the incumbent monitoring solution is simply not working. People will send the engineers to the field to collect the oil, the vibration, temperature data, which is inaccurate and very indirect. It's like using a thermometer or a blood pressure machine to try to detect your heart attack. So garbage in, garbage out, it leads to very inaccurate root causes and also unclear maintenance actions that fails to prevent this kind of catastrophic failures. We really want to change that with our hundreds of dollars AI IoT device built upon the Stanford groundbreaking inventions to capture the failures way before they strike, accurately, affordably, and also reliably. And more importantly, it's a non-invasive approach that can be clamped onto the ground wires or the base of the bushing for all types of transformers that doesn't require any shutdown for very quick installation. So why can we achieve this predictive maintenance so accurately? It's like ECG for transformers, where we directly listen to the heartbeat of this type of asset using electromagnetic signal at very high frequency and ultra low noise. I'm talking about tens to hundreds of megahertz, where we can precisely capture any small, tiny signals of the anomalies that will become catastrophic down the road. That usually happens in the nanoseconds regime. So with this type of capability, we can empower our AI digital twin solutions to help the asset operators pinpoint the root causes very accurately, know what to fix weeks to months ahead of time, and to really effectively prevent the outages, extend the lifetime by 30%, and also minimize the OPEX by more than 70%. So why can we accomplish this while people even like Texas Instruments or Allegro can only achieve 1 megahertz of the frequency limit, which is insufficient to capture this kind of signals? It's really a good marriage of two groundbreaking inventions here at Stanford, the high mobility gallium nitride Hall effect sensor coupled with the 2 omega signal processing, where we're able to overcome the fundamental challenges for traditional magnetic sensor at high frequency, where the current spinning really limit the signal to noise ratio and the usable data for traditional magnetic sensor. So with that, we're able to unlock 250 times more data from DC to 300 megahertz at ultra low noise to unlock this 95% predictive accuracy at an affordable cost. And hence, we can provide the Edge AI IoT device at only $500 per unit, coupled with our subscription model on the analytics platform. And if you look at the competition landscape, we're the only one that can provide very accurate prediction, but at sub $500 price point. And this is further validated by major users and big names like Meta, Siemens Energy, and Munich Re, HSB, major insurance companies in the field. They're telling us that having this kind of low, affordable, continuous monitorings for assets like transformers, switchgear, and capturing this type of very finicky signals for catastrophic failure like partial discharge is game-changing. And HSB is even telling us that this is like the thing, but for industrial applications that can disrupt the entire predictive maintenance space for electrical failures. As we go to the market, we plan on integrating the solution in the new transformers while retrofitting the existing transformer with our non-invasive solutions in data centers, IPP, and the manufacturing sectors, and eventually scale with utilities and the insurance companies. Currently, we already have 2 MOUs with major transformer OEMs, like GE, Air Energy, and also the over 8 LOIs with the major names and across the value chains like Meta, Qualitrol, Siemens Energy, and also CoreSite. And I just want to touch on that. This is truly beyond transformer. We can apply this to transform predictive maintenance for also switchgear, motor, inverter that you see everywhere in energy and also the manufacturing sectors. And behind all this, it's an amazing team. My co-founder, Yu Tong, who is also here, and myself are recent Stanford GSB graduate. Together, we have commercialized more than 10 deep tech products in big tech, national labs, and startups. And now we are partnering with the inventors of the solutions, Professor Sineski here at Stanford, and her students and the inventors to commercialize this technology to make long-lasting impact for the grid. So with that, currently we are raising $2 million pre-seed to deliver the major milestones for the hardware and the software solutions. So I will appreciate any introduction for the investors or the end users that may be interested in this solution. And with that, I'm asking you to join us to power a more resilient and sustainable future, and happy to answer any questions.
Wonderful, thank you, Joseph. And I believe this is something I mentioned, the aging infrastructure, right, could be very useful. So we have about a couple minutes to take questions. Any questions from the audience?
Great technology, congratulations. Do you have any sales as of today?
Not yet, we're pre-revenue.
I see, thank you.
So let me ask one. For the transformer health monitoring, And we can talk about transmission level, could talk about distribution, like secondary transformer. What is your minimum viable product, MVP, would look like? More focused on distribution side or more focused on transmission side?
Distribution side for now, yeah.
I'm just curious what your current unit price looks like, or if you have any manufacturing challenges for scale-up.
Yeah, good question. So everything is off the shelf. The gallium nitride is definitely a newer semiconductor materials, but Infineon, the semiconductor companies, was our partner before for the research project. So we're going to use them as a contract manufacturer. They already have the manufacturing line in Texas. So yeah, and everything else is off the shelf. And we will mainly be like a design company and utilize different players in the supply chain as contract manufacturing partners.
Very good. One more question here.
Yeah, what powers the sensors when you have them on all of the equipment? How is each of the sensors powered? Is it a battery that needs to be replaced, or how does that work?
Oh, yeah. So I think that's the beauty for Hall effect sensors. So the power consumption is super low. And we're going to use ASIC for the PCB to allow this high-frequency signal processing rather than FPGA, which is which consume more power. So our current prototype actually is using the indoor-outdoor solar solutions. But I do want to say for certain customers, they actually prefer it to be just directly connected to their security network. So we may not, for example, for data centers, we may not need to use the solar batteries. Yeah.
Okay, with that, let's give another round of applause to Joseph. Thank you, Magnefy. Appreciate it. The one after is from Pravah and Dhruv.
Hey everyone, my name is Dhruv. I'm a final year PhD candidate at Stanford. I focus on machine learning applied to power systems. I also used to work as a machine learning engineer at Google X at a team called Tapestry. Today I'm here to talk about our new startup, Pravah. We're building a grid intelligence platform that uses machine learning and agentic control. The reason we're doing this is because, as Joseph said, the electric grid is just failing everywhere. We're seeing outages in Spain and Portugal, India, the United States. It's no longer a local problem. It's really a global one. And the underlying causes are only getting worse. What you see here is a graph of extreme weather. In the United States, weather-related US power outages, it's been increasing year over year from 2000s to 2023. In fact, 2024 was another extreme high. And what this causes is grid failure. And this results in pretty hazardous economic damages. So because of grid congestion alone, US utilities borne $21 billion in cost in 2023. The same is true all the way around the world in India, where Indian utilities faced $11 billion in avoidable short-term power procurement costs, again, because of extreme weather and weather-related uncertainty. And so 3 of us Stanford graduates and students, we got together to solve this problem. Mohak, he graduated from the GSB last year, used to work as an economist at the World Bank. Aman has spent the last 10 years building machine learning weather prediction models for IBM and NASA, now finished his postdoc at Stanford, and then myself, I focus on machine learning. And the first thing that we did is try to speak to about 60 to 70 utilities from all over the world, and what we found is that everyone's really used to operating legacy electricity grids. They're centralized, linear, predictable, and measurable. But the future grid, or the current grid, is much more decentralized, non-linear, chaotic, and partially measurable. It's impossible to measure every single part of the electricity grid or do it well enough and have that inform real-time decisions. And so our solution is we're building a machine learning platform which becomes the world's best grid orchestration platform. We're laser focused initially on 3 use cases. The first one is forecasting electricity demand. This includes demand from large loads like data centers all the way down to the grid edge. The second one is energy supply forecasting. So both utility scale wind and solar and behind the meter solar. We've built machine learning weather prediction models that can forecast from seconds to 14 days ahead. And these two tie into the third piece, which is congestion management. So where in the grid are lines going to be most congested? Does this have an impact on transformers? How is this going to impact my operations today or long-term planning from a year or two from now. And the technology behind this has been the focus of my PhD. Spent the last couple of years developing it. It's powered by graph neural networks and transformers. So we do a bunch of forecasts. So demand forecasts, weather forecasts, latent variables, fuel prices. We're integrating with the SCADA that utilities use. With this information, we map the current state of the grid. And then we use this to forecast the next state. And that delta can be anywhere from a few minutes to a few days, for a day-ahead market, a few weeks, all the way up to a few years. And going one more step further, instead of using deterministic point-based estimates that everyone is so used to, all of the outputs are probabilistic. So we represent the uncertainty of our estimates, what's driving that uncertainty, and that gives operators a better sense of control and just visibility in what is to come. How this competes with existing players, so we're not replacing legacy companies like Schneider Electric or GE Vernova that have centralized distribution management systems. Our goal is to augment these systems. How this differs from other startups, I used to work at Tapestry. They've spent 7 years in this space. I just feel that there's a void, which is there's no scalable product that's applicable across geographies. And in all of the work that we've done in the last 6 months, I'll come to this, but we're piloting in India, in Colombia, in Chile. So it's really scalable across different market operation patterns. And just, it's a plug-and-play solution. These tools have been proven to be state-of-the-art. So when I worked at Google, I was employee number 1 on a new tool for real-time operations. In 90 days, we worked with the Chilean system operator to build a better weather prediction platform. They were using a numerical model. We built a machine learning model. And 91st day, it was deployed in the control room. So we outperformed every other global benchmark by 30 to 40%. And what this resulted in was lesser curtailment of wind and just better visibility. Use cases are very diverse. It's not just targeting utilities and system operators. So one use case is obviously for utilities, which is where is demand going to peak? Where should we direct capital? The second use case is for generators, which is what is the weather forecast and output for the next day, for the next 7 days? A third use case is for distribution companies, which is what is the line loading with best and worst case probabilistic scenarios. And these tools are really versatile, which is why in just a few weeks, we've already signed 3 pilots with Indian utilities. So the top 3 Indian utilities, as well as we're in final stage of pilot scoping with CAISO, which is California's grid operator, ERCOT, which is the operator in Texas, as well as PG&E. And together, all of our pilot customers cover 70 million consumers and have 150 gigawatts of operational capacity. And just to give you a sense of how we signed that pilot with Reliance's utility in India, which is India's second largest utility, Mohak, which is my co-founder, presented at a conference. And this is a really weird picture with circles around 2 people's faces. But the CEO of that utility reached out immediately. And within 5 weeks, we started our pilot engagement. And from day 1 of the pilot, we're showing improved value. So the Reliance utility, their error of forecast was between 5 and 6%. From day 1, we brought it down to 1.5%. So with limited data integration, we already show value across one of the 3 verticals. Please feel free to reach out. We just finished raising our pre-seed round, now looking for just more partners to work with, or if any of you have any contacts with utilities, grid operators around the world, we'd greatly appreciate it. Thank you so much.
We can take 2 to 3 questions. Have time? Any questions?
Could you elaborate a little bit more in between weather forecast and energy demand and energy supply forecasts? Weather is definitely one contributor, but that's not the only one. So are you providing weather forecasts or energy demand and production forecasts?
That's a good question. So we start with weather forecasts. We're building our own weather model. We're taking an ensemble of models out there, and then we convert that into an energy production forecast using local supply curves. And we downscale all the way to 1 kilometer by 1 kilometer resolution at a 5-minute interval. So both spatially and temporally, it's really granular.
So your 30 to 40% outperformance is really impressive. And I think it could be enough to shake loose some of these customers that you're targeting. You clearly have some pilots. Wondering about your customer set is so risk averse across the board. which makes sense because of the applications that you're talking about here. How do you get over some of the hurdles around adoption of new technology and risk of failure at an important moment? And have you plotted that out in your commercial discussions for post-pilot?
That's a really good question, and to be honest, we're still figuring it out. So as an engineer, I want to deploy my solution in the control room in day one, but that's just not how it works. So that's why we've spent most of our time. The roadmap is such that we require very limited integration. So we're one of probably 3 providers that a utility would use for either demand forecasts or renewable forecasts. And then as we get closer to their core grid operations piece, that's when we would have to show reliability over, say, a 1-year pilot period. But this is really an open question. Utilities in India have been really fast because they are really struggling. I would say they're at level 1 of technology adoption, whereas US is at level 3. But what's happening is they're leapfrogging straight to level 4, and we think that we can help. In the US, it's been slower, so we're still scoping the pilot with PG&E, with ERCOT and CAISO, but again, we're one of 3 vendors that they use, and the goal would be to show how much better our forecasts are compared to anyone else before integrating further.
Okay, with that, let's give another round of applause to Dhruv. Thank you very much. Okay, let's move on to our next one, permitting, which is a very important topic for extremely large, for any infrastructure problem in the United States and also globally. So next will be on the stage Emily from the PermitPal.
Good afternoon, everyone. It's lovely to be here. My name is Emily. I'm joined here by my co-founder, Camilla, and we are the founders of PermitPal. If you ask a renewable energy developer what it takes to build clean infrastructure in the US today, they show you a picture of a banana. Now, what that stands for is build absolutely nothing anywhere near anyone. Banana. And that's exactly the problem that we are trying to solve at PermitPal. Today, 30 to 50% of clean energy projects are facing cancellation or delay. And the reasons for that are because of community opposition and slow access to getting local permits approved. What we do at PermitPal is we are building the world's first map and database of all projects that have been permitted historically, mapping out the reasons why that has happened, why certain projects have been rejected, and helping developers understand, firstly, where they should be citing their projects, and secondly, how they can most effectively engage with communities who live locally. We help developers understand permitting histories, regulatory complexities, as well as important features of the communities that they're hoping to build in. What is it that is really important to this community, and how can we design benefits packages that actually appeal to what these individuals want? The way that we're doing that is by building an AI-powered web scraper that goes through hundreds of thousands of local meeting minutes, public news sources, social media records, so that we can build these detailed maps and profiles of what communities want and need. The first aspect of our tool, as I mentioned, is the siting analysis, where you can understand the permitting history. And the second part is helping developers really identify who the key decision makers are, how they can influence them, and what different strategies grounded in behavioral science might look like to work more effectively with local partners. We're partnering with local government and with local nonprofits to help provide lists of, when you go into a new region, who are the people that you should be engaging with. So far, our primary customers are the vice presidents of project development at large renewable energy developers. And the direct users of our platform are community leads and siting leads within these organizations. But that's not where we stop. We view this as a tool for the entire community. We're working with different community partners to really bring the platform to life, and moving forward, want to build proprietary data partnerships with state and local government. Where are we at right now? We're currently running our first pilot with a large renewable energy developer, and we've got plans to launch 2 more pilots over the next 3 months. Our existing pilot partner has just extended the use of our platform for another 6 months so that they can continue to use the product as they continue to build out another 50 to 60 projects over the next few years. We've secured grant funding, and we're looking to raise pre-seed funding later in the year. So if you are an investor, do come and find us afterwards, and we'd love to chat. How are developers solving these problems right now? At the moment, the traditional method is to use consultants. You go to a siting consultant or a political consultant who might be able to provide some insights into what the product, into what you need to be doing. However, this is time-consuming, inaccurate, and often extremely expensive. What PermitPal is able to do is automate all of this, such that when you are looking at what counties you want to build in, you can get almost immediate access to the data about the community needs. Where we're going in terms of the business plan is that we plan to charge an annual license fee as well as a success fee on the product in order to make sure that we're actually delivering value. We think that our incentive should be directly tied to, does your project actually get a permit, and are we really able to help our customers do the things that they want to achieve? How can you help today? There's a few things that we'd love from you. The first is we're looking to find more pilot partners. So if you have any connections with renewable energy developers who have faced historic permitting challenges, we'd love to chat. We'd also love to speak if you have insights into any counties that you've come across in your work where you've seen particular tensions between communities and developers, such that we can focus our R&D efforts on those particular places. And we're looking to build more partnerships out with local and state government. So if there is anyone here from a political perspective, again, come and find us. We'll be at the Startup Expo table afterwards. We're PermitPal, and our vision is a clean energy transition powered by community and developer collaboration. Thank you.
Wonderful, crystal clear. And you buy yourself more time for Q&A. Any questions from the audience? Let me start one for you, Emily. So this is wonderful in how you use the language model, be able to trace all the meeting notes, etc. How extendable of this technology for different energy technology? Because for sure you're working on the wind and the solar renewables. How about energy storage? How about hydrogen or even the electrification, like EV chargings or data centers or manufacturing load? How extendable this technology to other electrification or energy transition technologies?
That's a great question because it gets me to boast about how we can expand the TAM, and that's exactly how we plan to do it. There's nothing about what we're building that needs to be specific to renewable energy developers. We started with that market segment because it's the market that I understand the best and that Camilla understands the best, having spent a lot of time working in the renewable sectors. But you're totally right that this is applicable to any kind of clean infrastructure where you need to go through the permitting approvals process and where you need to build local support. I think, sadly, one of the things that we're seeing across the US is that there is increased ideological resistance to a lot of clean tech infrastructure. And as such, really understanding then what are the other ways that you can work effectively and negotiate with local communities, given those barriers, is becoming increasingly important, whether you're building a sustainable aviation fuel factory or whether you're building a solar energy plant.
What's your revenue model? Is that a SaaS or DaaS? How do you sell this?
Yeah, so the revenue model that we're targeting is essentially a combination of a SaaS-type model with an annual license fee and tying our revenue to the project success. So if your project gets permitted, having used the PermitPal platform, then we would charge a success fee on the basis of that.
What success metric do you offer to your customer?
In terms of...
What's the, if I come to you, I buy your service, what do I anticipate getting at the end of it? A permit?
Yeah, so the ultimate goal from both your side and our side is that you get to NTP, notice to proceed, and that you're able to actually, start get the permits approved and then sell on to the operators of the plant moving forward. So that's the end goal from both sides.
And are your fees at all tied to that outcome?
Yes, exactly. So the success fee would only be contingent on the permit being approved by the local county and that you're able to get to NTP.
Wonderful. Let's give another round of applause to Emily. Appreciate it. Let's move on to our next pitch from ElectricFish. Anurag? Yes. The stage is yours.
Hey, everyone. I'm Anurag from ElectricFish, and the story today is about rebuilding our entire electrical grid using these boxes. This is one of the units which we shipped last week to one of our customers, Hyundai Motors, to their innovation arm. A lot has already been said today about how the grid is really old and how the permits are becoming really slow to rebuild it. And that's what we're trying to do. We're trying to create a new generation of electrical grid, which is built by using these decentralized energy storage units, which can truly make the grid a bidirectional place as compared to the one-way flow of energy which happens today. But today the problem to be solved is a narrow one. We are helping electric vehicle fleet operators to get very fast infrastructure at their place. The momentum of electric vehicle fleets was a lot in the last few years. Fleet operators or fleet managers started to buy electric vehicles. They bought 3-5 vehicles to start to play with. And they tried to fit the electric vehicles in the same operations which they were doing with their gasoline or diesel fleets. But they could not get the fast infrastructure or any kind of like operations to just fit in the same use case as conventional vehicles work. And if you bought a vehicle fleet of 10 vehicles, then you're started to lose 200,000 per year. And then if you're dependent on public charging infrastructure, then the cost was almost at par with gasoline. So few of them have turned back. They've started to go back to diesel. And the whole movement of electrification of fleets is kind of at risk. And that's what we're trying to do. We're trying to get fleet operators their fast charging infrastructure at their place using our devices. We call it the 350 squared. It's a massive battery, 400 kilowatt-hour battery pack, which connects to the same electrical grid which you have at 100 amps to 8-volt three-phase, and is very quick to deploy because you don't need permits. You do need permits to just let the AJs know, but you don't need an electrical upgrade. You drop the unit, you hook it up to the same electrical grid which you have. It stores that energy over time and delivers very fast charging sessions, even 40% faster than the Tesla supercharger network. And we have designed it to be quasi-permanent or movable. That means that it gives us and our customers the operational flexibility to play with such a fast charging solution with the existing infrastructure. And we have got AI or optimization on top of it, which enables the long-term vision, which I talked about. This solution is holistically integrated with electrical grid. It's truly a bidirectional device. It stores energy in, but it can actually export energy back to the distribution grids as well. That means there's another piece of the business in which we can participate in grid services and monetize the energy. We also have a monitoring platform. We call it the Reef, which forecasts EV charging demand. It's able to take user inputs on how much energy they want to be backed up, need for backup, and how many vehicles they want to serve every day. So holistically, integration with electrical grid makes our business model a little bit more nuanced than what you think from a hardware manufacturer. Today, we make 74% of our revenue from upfront sales of hardware. Not very high margins because we don't want to outprice ourselves of the market, especially Chinese competition. But then there is a monthly subscription and a hardware lease model, which is a recurring part of our business. Today, it's around 25%. And then selling energy back to the grid did make us money around a percentage of our revenue last year, but that'll grow to up to 8 to 10% in the next 5 to 7 years based on the current go-to-market which we have. So we have built these units. So far, we have deployed in various US states, Detroit, Los Angeles, New York, Boston. And now we have started to build 1 unit a month. These customers are operating some sort of fleet at their facility, or they're deploying them, or like vehicle distribution centers like OEMs. And we are selling to the US Air Force. That's one of our biggest contracts. And auto OEMs are our distribution partners. And then cities and municipalities make the third of our segment today. The total weighted pipeline, just to give a whole sense how exactly our business is unfolding. Federal and municipal fleets, they do make our biggest of our segments today. And they are grant funded. And the way their operational cycles work, they want to buy the unit up front. So only 6% of them are leased. That means this is my favorite model. I want to make the money up front, not have a very strong balance sheet as a small company right now. But corporate fleets are second of our biggest customer segments, around 28 active deals. But 50% of them, more than 50% of them, want this over a lease. That means we need to take the cost up front to try to make the money over the first 2 to 3 years of operation. And that's why we are raising. I'll talk more about that. And then there are some other emerging segments. Utilities are looking to buy it for their own fleet operations, as well as entertainment sector, like Netflix and Disney. They're electrifying their fleets, and they want fast charging solution for them. So this is kind of all of our pipeline. Today, the go-to-market strategy definitely revolves around medium-duty fleet operators throughout OEMs today. And then the next segment is to help infrastructure developers like the Electrify America, EVCos, or the IONA network, which is coming up, to downsize their overall interconnection requirements by 1/10 and still do very fast charging sessions and keep the lowest cost of operational electricity. So how do we beat the competition? Where exactly are we competing against them? When you stack up competitors as well as legacy charging infrastructure like Tesla or the ABBs, we are the quickest to revenue. We will get you the charger live in 2 weeks. At times, it just takes us a few hours to activate it, and that's our last 3 deployments, as compared to more than 2 years, which it could take you 6 months to 2 years, which would take you to get the electrical permit and get it operational. In terms of upfront capex, we are almost at par, even if we have a massive battery integrated with it. This is because we have got the permitting expenses just nil, and then we can just deploy, and it's very operationally flexible. And then finally, in terms of long-term operating costs, is where we really beat competition, because we've got intelligence to figure out when is the cheapest cost of electricity. We have the storage, as well as we are not paying any peak and demand charges. And then we can reduce your local electrical bill and monetize the electrical grid. So it's significantly low operational cost for our solution. So with this, this is the team. I come from BMW's tech office, not so far from here, and then Department of Energy, working on battery systems. Nelio, my CTO, is from NASA. Actually wrote firmware, which went to space. Vince grants. That's how we've been building the company so far, significantly, 50-50 split of total money raised. And then we have got Fowler from Stanford. Currently, she is advising the optimization engine build. And then our team advisory team comes from both fuel distribution space as well as utilities. Now, we are going to raise a Series A, 11 million. The goal is to build the first 100 units, deploy in certain geographies. California and Michigan is our go-to-market, and then get our margins high. So far, we have raised around 3.8 million from MSF Strategic, some VC funds, as well as non-dilutive capital from California Commission, State of Michigan, and State of New York. With this, at the end of my presentation, these are our customers and funders, and I'm open to questions.
Wonderful. Any questions? Let me get started. Okay. What's your thoughts about the different energy storage technologies' impact on your business or business model?
It's helping us. We are agnostic to the battery chemistry. We do want to just buy the safest and potentially the cheapest solution which is out there. We're using iron phosphate right now. We're looking at some zinc-based chemistries too. They're just big. These are urban settings, so we want a smaller form factor, as well as the cost of energy storage has just dropped precipitously. So it's definitely making our business model much more lucrative. Yeah.
Now we get exciting. People, our startup start to challenge each other or comment to each other.
So when do you trickle charge these on like 220 or something like that? And then when you're doing that, how many cars can you charge per day? Is that a major kind of limiting factor?
So theoretically, it does. It is a limiting factor of the technology itself. The way I like to answer this question is that in the whole electrical grid stream, somebody will own storage. Either the utility will on a utility scale, or there will be a community scale, or the homeowner owns a battery. So what we're trying to crack is at this community or a business scale right now. And the utilization currently, which we promise our customers, is around 35%. So you can do up to 25 to 30 cars every day from this interconnection. So it takes us around 6 hours to fill up the whole battery. But the battery itself is massive, 400 kilowatt hours, and every session we are delivering up to 25 to 30 kilowatt hours. So we have got a lot of operational flexibility with this product, and there is a utilization. It's not like you got continuous sessions happening. There are peak hours, and that is why we have the optimization engine to forecast when exactly the vehicle will come up, and you plan for that energy.
Thanks for a great presentation. What are the scaling challenges or limitations at this point you are facing, and how you want to overcome those barriers?
We have been lucky. There have been other companies in this space who have raised a lot of money, failed, or given us data points on how to do this. One of the biggest challenges which I see for scaling is to figure out how to keep our servicing costs low. We also always get this question on what exactly are our competitive mode. It's just a very complex product to operate. And then also making sure that you can keep making the operational margins on the servicing. Customers have been spoiled, not want to pay for servicing, and that could be a potential revenue stream. So just making sure that how do we expand with geographies which we pick? Do we have partners in place so that we can make the servicing as an operational advantage as compared to making us bankrupt? That is the biggest challenge to figure out, and we're trying to just buy components which are going to be robust enough and test them beforehand.
Okay, wonderful.
Thank you, everyone.
Let's give another round of applause to ElectricFish and Anurag, please. Thank you. Now, next one coming to the stage is, now you see like we are moving from pre-C, C to A, then A to B, get more and more mature, and we need more help, more than just the money, right? But also really the ecosystem to help us to scale the technology. So the next one on the stage will be the Axiom Cloud with Amrit. The stage is yours.
Hi, folks. My name is Amrit. I'm the CEO and co-founder of Axiom Cloud. So we definitely have an energy bend to what we're doing, but we're in some ways focused on kind of a broader set of problems for a very specific industry vertical. So we're focused on refrigeration. Specifically, we're trying to build the AI and cloud platform for the cold chain. So refrigeration is the elephant in the room for our first and biggest customer set today, retail grocery. It's 50 to 70% of energy usage. It's 90% of maintenance. It's the whole ballgame for EPA, federal and state level regulations. And for each of our customers, it's over 50% of all of their Scope 1 greenhouse gas emissions. In many cases, it's 50% of their Scope 1 and Scope 2 emissions for the entire grocery corporation, this one asset. And each month, the typical US store is spending more money just to power and maintain its refrigeration system than it takes home in profit. So obviously very important, but we're still ignoring the most important piece, which is selling groceries. So when the cooling goes out in a grocery store, that is kind of the nightmare scenario. There are a lot of really visible impacts of that, but it also invisibly affects every part of the entire business model, even down to things like customer loyalty, where if the cooling goes out and your freezer aisle's out for 4 hours, you might alienate 100 customers who aren't going to come back next week. So massive bottom line impact of an outage, but also immediate top line impact. So despite all this, our customers today don't have the tools to address the root cause of these really painful issues when it comes to their most mission critical asset, refrigeration. Maintenance today is a completely reactive break-fix strategy. So every single problem is an emergency and it's a surprise. And there's no data, and this is all being exacerbated by a shortage of qualified technicians, which is getting worse, not only in the US, but also in Europe, Australia, Asia. Energy it's not a great status quo. We're kind of stuck in the 80s in our industry, where every 3 to 7 years, a grocery store or the corporation that owns it will send a commissioning team into that facility, and they'll spend 2 to 5 business days on site, costs $15,000 in many cases, and they will do a fantastic job of reducing energy consumption of that facility, focused on refrigeration, because that's where most of the energy is going. But then the rule, not the exception, is that the majority of that value of those savings disappears in a matter of weeks after that commissioning agent leaves the store. And that's because the local maintenance technician, we pay them to get in, get the food cold, and get out as fast as possible. The easiest way to do that in many cases is to turn off all the fancy energy efficiency algorithms and things like that. That's not their fault, that's our fault as an industry for forcing them into that position. Refrigerant leaks are the worst of all here. So zooming out a little from just energy, looking at sustainability, refrigerant is an incredibly potent greenhouse gas. You leak 2 pounds of this stuff, that has the same impact as driving your Toyota Corolla for an entire year. And a typical grocery store leaks 800 pounds of this stuff per year. This has been called the single largest opportunity for humanity to reduce climate change is to fix this refrigerant management problem. We'll talk more about that in a minute here, but the status quo in our industry is that you don't know when there's a leak. It's kind of like driving your car down the road without a gas needle, and everything's fine until it isn't. Then you're on the side of the road and you're out of gas and your whole day is ruined. Today in this industry, you don't know if there's a leak for 6, 9, 12 months in some cases until you've lost 1,000 pounds of gas, by the way, which costs $40 a pound. And then you have a 1 to 2 day outage and you're throwing out $400,000 worth of product. It's a really bad status quo. So at Axiom, we're taking a playbook that's already been successfully applied in almost every adjacency. And so the idea is let's take the data that we already have from the 500 to 2,000 sensors in each facility, send it to the cloud, clean it, label it, normalize it, then do useful things with it, which ultimately then can result in predictive analytics, but then also actions and measurable business outcomes. We'll talk more about that in a second. But ultimately, we're going to market today with 5 subscription-based modules. Each one of these solves the single most important pain point for one key stakeholder sitting at corporate headquarters. We're talking about the metric that defines whether that person gets fired or whether they get a bonus at the end of the year. And each one of these speaks to one of those stakeholders. So how does it all work? Today, so this is a fully remote software-only solution. We are connecting to the existing refrigeration controllers in our customers' facilities via APIs, via a whole different library of different APIs. And today we're compatible with about 95% of grocery stores in North America and about 40% of cold storage facilities. Today, the core of the technology is AI. And this is not Gen AI. This is kind of the last iteration of AI. And we're training this AI by looking at 1,000 or more historical years of data across a super wide variety of different sites that tell the AI what is good, what does normal look like. And on top of that, we have another data set of 80,000 human-labeled anomalies, problems or opportunities that have occurred. Each one of them, when did it start, when did it end, what's the root cause? By feeding those 2 different sets of data into our AI algorithms, we're able to determine what are the leading indicators for that next big problem, that next big opportunity. And at this point, the AI algorithms have gotten better than our human operators, and we're consistently being surprised by how good the results are. So I'm not going to go into too much detail here, but ultimately, if you're looking across an enterprise, today we're in about 1,000 facilities. Some of our big customers are Target, Sprouts, HelloFresh, Lineage Logistics, et cetera. Ultimately, we're pulling an enormous amount of data from their facilities. We condense it into a very small number of very actionable opportunities. But the interesting piece here is that when we hand our customer what is arguably the best work order they've ever seen, it tells you where's the problem, what's the root cause, how much is this going to cost me if I don't do anything about it, and then show me a picture of what's going on using data so that I as a human can understand what it is and also believe it. This is not just an AI black box. And then from there, what are the specific steps required to resolve that problem or address that opportunity? And then, that's essentially what we're sending our customers, but we send them a stack of these things, and they tell us, not only do I not know what to do with this, but I'm annoyed by it because I already have a boss. I don't want someone else to give me a to-do list. And so, this is a key part of us in our journey over the last 5 years of finding product market fit, is realizing we have to go much further than that. We have to hold our customer's hand through the next couple of steps in their process as well. We paid our tuition here. It was painful, but we got through it. Ultimately, where we are today is we go to market as it's almost like a service-enabled software in some ways, in the sense that we are there holding our customers' hands every step of the way, but at the same time, we've managed to thread the needle by using automation to still achieve very, very solid SaaS margins. And so ultimately, that means helping our customers to figure out which ones of these can I resolve remotely, and then which specific technician should I send to which specific store on which day, spoon feed this whole thing to me. And then from there, it's validating results. So how many service calls did I avoid? How many kilowatt hours of energy did I save? Pounds of CO2, and ultimately dollars. So that's our business model. Ultimately, we do have a lot of big blue chip customers at this point. We're growing very fast. We've almost tripled in each of the last 3 years, and that's going to get harder and harder to do because we're not starting at zero anymore. Ultimately, we're able to provide a lot of value for a lot of different stakeholders, which means that we have 5 discrete entry points into each big corporate account, which helps a lot from a go-to-market standpoint. and also gives us limitless opportunities to expand and drives a lot of stickiness as well. So I wanted to touch on the climate piece just because of the audience today. This is what gets me out of bed in the morning. Ultimately, these F gases, or HFCs, as we call them here in the US, represent more emissions than cement, aviation, and shipping. It's just an absurd amount of contribution to overall climate change. Again, leaking 1 pound of this stuff, very impactful. Leaking 2 pounds of it has the same impact as driving a car for a year. And then a typical store is leaking an enormous amount of this stuff. If we were to solve this, this would be incredibly impactful from a climate change standpoint, and Project Drawdown does name this as the #1 opportunity for humanity to reduce climate changes. Let's just simply stop leaking this terrible stuff. That's where I'll leave it. Thank you.
Very good. We can take a couple questions. I have one question there.
Hi. Excellent presentation with a clear problem statement. I think I will remember your problem statement for the next 10 years. Here's a question. You mentioned this problem has been existed since 1980s. 55 years later, why do you want to solve this problem now?
Yeah, that's fair. So the problem is getting worse because of the shortage of technicians, rising costs, and then increasing focus on budgets, and honestly, margins as well are very, very small in this category. Typical grocery store has about 1.3 net profit after taxes over the last 10 years, including last year. And there's a lot of additional pressure from tariffs and uncertainty, and you guys know all the rest. But ultimately, so the problem is getting more painful, but on top of that, now we have the opportunity to help our customers get from where they are today, which is, okay, now I can see my data remotely for the first time. That's it. Now let's take this playbook that we've already applied successfully in almost every adjacent market, cloud, analytics, AI, and automation, and let's take this proven playbook and drop it in with this data that you already have available on the internet today. And so also the opportunity has presented itself. I would say those are 2 reasons. And the third is that I wasn't even born in 1980.
Okay, let's take another quick question here.
Here's one quick question. Do you have a hardware that you have to install at these locations to add additional sensors, or do you look only at their electrical utility data that they share with you through various means?
This is a fully software-only solution, and we get anywhere from 500 to about 1,500 data streams from the refrigeration controllers in each of these facilities. And really interestingly, if you walk into a grocery store in the back, there's these massive refrigeration systems with a controller bolted on the side of each one. There's 1 to 3 of those controllers. And so it's 1 to 3 integration points for us that give us the entire gold mine of data for that entire facility. And there's no master level controller that sits above those. Those controllers are also playing double duty as the HVAC and the lighting controllers.
Very good. Thank you, Amrit. Appreciate it.
Thanks.
Next on the stage will be Buzz Solution and Vikhyat. And actually, next 2, they were here last year. So I'm very excited to see how quickly both companies grow over the last year. So stage is yours.
Thank you, Liang. All right, good afternoon, everyone. I'm Vikhyat Chaudhry, co-founder and COO, CTO at Buzz Solutions. And at Buzz Solutions, we are providing a vision-powered intelligence platform for modernizing energy infrastructure. So a little bit about who we are. So we launched in 2017 out of Stanford University. Currently, we are serving power utilities, electrical power utilities market. We are a team of 35 people and growing. Actively, we have projects with multiple different utilities in 4 different countries and 8 US states. We are headquarters locally in Palo Alto. And what we do is we provide an AI-enabled software platform that automates visual data inspection and analysis. So we're doing inspections for transmission, distribution assets, and infrastructure, but we're also monitoring our substations. Just to highlight a little bit, and most of us know about all the different kind of urgent challenges that are happening on the infrastructure for utilities, but just to highlight a few, there's outages happening, so reducing outage minutes is critical for utilities, and because of lack in maintenance and not timely maintenance, we're facing events like wildfires that we all probably know that. And then there's events that are happening on the disaster side due to storms as well. And then in the recent years, we've seen substations are becoming a threat. So there's threats at substations, there's vandalism, there's domestic threats that are on the rise as well. And then the third piece is there's an aging workforce. So 50% of the field workers and engineers are retiring in the next 5 years, which is a big problem for utilities. Lastly, our aging grid infrastructure requires much more faster grid modernization efforts. So how do we help? We help utilities deploy this software platform, which is powered by our core computer vision AI models. And this helps utilities with improved asset management and provides a much more resilient grid. We also increase reliability for our power utility partners and reduce outages due to proactive and faster maintenance. We also provide enhanced security, safety, and equipment condition monitoring for substation infrastructure. And all of this causes a lot of increased efficiency gains, operational efficiency for utilities. So massive time savings, a lot of optimization of resources, cost savings. And then lastly, I would say this helps utilities to do much more frequent inspections. It helps them scale their inspections and maintenance programs much more scalably and brings up a lot of efficiency gains over there as well. So how it works. Our core product solutions and platform rely on optimization of inspections and monitoring of different infrastructure assets. So there's 3 components. We analyze visuals, so we take in massive amount of visual data captured from drones, helicopters, fixed-wing aircraft, fixed cameras. To give you an example, PG&E captures 15 to 20 million images every year on their infrastructure. So we take all of that in, we manage all of that data securely for our utility partners, and then we process all these millions of visuals with our proprietary AI models to find any kind of defects, insulator damages, overheating in power lines, transformer damages, all of those kind of situations. Then we alert the teams proactively. So we empower the right people at the right time. So operations folks, maintenance folks, field engineers, we give them all this information at the right time. And what it does is accelerates all the operations for them. So it improves their asset replacement programs. It improves their inventory management programs. It prevents outages to happen. And obviously, as I mentioned, it improves their operational efficiency as well. So in a flow diagram, the workflow for utilities with this kind of solution, and I will highlight our first product, which is Power AI, that is for transmission and distribution line inspections. How this workflow works is, let's say drone operators go out in the field, they collect massive amount of imagery around their transmission or distribution assets. What they can do is then they can bring that information back to a cloud-based, web application-based software platform, which is called Power AI. We ingest all that data, we map it where all these assets are located. So we are partners with Esri. So all of that GIS capability is provided by our software. So now the operators know where their assets are located. Once we have geotagged all these assets, we analyze and process all this data to find any kind of anomalies or defects on the power line or assets itself. And then lastly, we tell utilities what they can do about it. So we prioritize all this information for utilities. So now they know which areas to target first and which areas to kind of see in the next few weeks. So all in all, what it does is we take all this information and results and we make it much more actionable because we integrate all of this information into their asset management systems or work order management systems, which helps them prioritize their work orders. And here's a visual about how the software looks like, and then some of the results. As you can see, some examples over here where components like insulators are flashed or damaged, and then there's vegetation problems highlighted by our AI as well. But all in all, the features include, as I mentioned, data ingestion and management securely and safely and scalably, but also automated data analysis. So we have models for insulators, for structural damages, for vegetation encroachment, conductors, and all of these models have been trained across 10 to 15 years of historical data across 40 to 50 different utilities across 8 different countries, and our training sets now comprise of 250,000 and even more data points, visual data points that we have collected over the years. So these models are operating at a very high accuracy, 90% and above baseline accuracy. We also include an inspector in the loop workflow, which is basically a human workflow, which at the end of the day, we want utilities to make the final decision. So their subject matter experts are the ones that are vetting this or validating these results from the AI. And lastly, I'll highlight that the workflow integration piece is very critical for utilities. We want all of these insights to become actions. So we integrate with GIS, asset management systems, and work order management systems for utilities. Our second product or solution is called PowerGuard, which is for substation monitoring. And the workflow, how it works is, so this solution is deployed on the edge. So we have our proprietary AI models deployed on the utility substation cameras, and then we monitor all the video feed coming from cameras, both optical and thermal. So these models are looking for security issues. Let's say there's an intrusion from a person or vehicle or even animal. That's a big problem for substation operators as well. And then safety issues, like if the personnel is injured on the site. And then obviously we're doing asset management, so looking at equipment conditions. So if there's transformers overheating or there's insulators damaged, bushings that are damaged. So looking at the condition of the equipment itself to give all of these insights back to the operators so they can take some action. Just to highlight a few examples over here. So as you can see, we're detecting with our AI if there's any fire or smoke kind of situation happening at substations, or if there's equipment like insulator damaged. And I want to highlight a really critical part over here is the way we train some of these interesting anomalies like fire and smoke where there's lack of training data. And obviously we cannot go to a substation and light it up on fire to collect some training data. What we did was we used cutting-edge Gen AI and synthetic data generation models. So we modeled the substation in a 3D, in a game engine, and then started putting different signatures of fire and smoke. And that resulted in really high degree of accuracy of the model. So that's a highlight over here where how we have trained some of these less frequent anomalies as well. To talk a little bit about our customers and partners and how they're using us, first I'll highlight some of the proven successes with utilities. So we are at scale. We started doing pilots and POCs in 2021. We went through multiple EPRI Incubate Energy Labs programs with multiple utilities. We started scaling in 2023, and now we're working with some of the prominent investor-owned utilities and public power utilities like Dominion Energy, New York Power Authority, SoCal Edison, Entergy, just to name a few. And I want to highlight how Dominion has used us. Just last week, we analyzed 45,000 different transmission structures for them, around 100,000 images, and we analyzed and processed that in 10 hours, which would have manually taken them 3 to 4 years. We have a healthy industry partnership ecosystem as well. We partners with Esri, EPRI, Power Engineers is another big partner of ours, and then we partner with manufacturers like Skydio who manufacture drones, and data providers or data collectors like Accurant, Drift Enterprises as well. So that's a little bit about us. I'll take some questions as well, but look, we are looking for partners and customers and even investors to talk more about our pipeline and our roadmap forward. But thank you so much.
Thank you for Vikhyat. We can take 2 quick questions.
So you mentioned you have about 35 people in your company?
That's correct, yes.
So what stage you are in fundraising?
We're Series A.
Okay, so you are raising Series A or you already raised Series A?
We have, but we'll be raising another, so we're reaching towards Series A. We've raised multiple seed bridges, and now we'll be raising a larger round around October, November timeline of 15 million.
I see. Yeah. Okay, thank you.
Until date, we have raised $12 million in VC capital funding.
So wait for 2 to 3 months.
Yeah, my question specific is on the optimization. Can you give briefly your vision when you incepted? What was your optimization level versus today, and what do you hope to accomplish in the next couple of years?
So optimization for resources and time and
Yes.
costs for utilities?
Yes.
Yeah, so when, and I'll give an example of one of the utilities we worked in Canada. So before using us, they were spending, and this is an anecdote metric from them, is they were spending 30 minutes per pole inspecting that. After using our software and AI, they were spending 1.5 minutes. So just a massive amount of time savings, and that is associated with cost savings, because now, as you can imagine, a lot of utilities don't have to send out field workers out in the field. They can remotely see how their assets are looking from a 360-degree angle, aerial vehicle image capture, and then now they know what kind of problems are happening, where they're happening, and how prioritized they are. So massive amount of cost and time savings for them.
Okay, thank you for BUD Solutions.
Thank you.
Let's move on to the last but not least. We have Derapi and Thomas Lee from Derapi.
Thank you, Min. Thank you, Liang. Thank you, everybody, for being here. It's nice to be back again. My name is Thomas Lee, not to be confused with the electrical engineering professor here, but I am the founder and president of Derapi. It is an acronym, so Distributed Energy Resource Application Programming Interface. We are building a digital hub, a universal translator for communicating with behind-the-meter energy devices. A little bit of background. Yang mentioned it earlier, right? We're facing unprecedented load growth here in the U.S. DOE sort of estimated we need about 200 gigawatts of peak generation available to us by the end of the decade. This is lightning fast for the utility industry. This need is also actually colliding with actually an interesting reality of electricity economics, is that now it actually costs more to move electricity than it does to make it. Right? This is actually screenshots from my own electricity bill. And you notice I pay almost twice as much for transmission and distribution as I do for generation. So this is driving value, all right? This is driving actually a demand for distributed side resources, customer-sided resources, because you can actually address capacity needs faster and cheaper by doing it at the end of the grid. Problem is, these are actually highly underutilized resources, right? This comes from another DOE report. In the last 6 years, we've installed somewhere between 140 and 180 gigawatts of capacity on the distribution grid. Only about 33 of it is actually enrolled in a virtual power plant, right? A program that would coordinate these to be able to work together to provide the capacity that we're looking for. One of the reasons is that in order to do this, you have to talk to all of these devices, right? And this is where a big bottleneck happens, because if you are someone who's trying to build one of these applications that works with these devices, say a virtual power plant, one of those folks in orange on the right, you have to form an integration with each one of those devices that are on the left. And it's not just a software, like technical integration, right? It's actually a business relationship as well. And each one of those are bespoke. Right? There's no widely applicable standards. It takes a long time to actually put this stuff together. And it's not a challenge not only for the folks who are actually building the applications, it's actually a big challenge for the manufacturers as well, because they're getting requests from all these different entities who want to interact with these devices. Think about if you are, say, a battery manufacturer, there are 3,000 different utilities in the United States. If each one of them is coming to ask you for an integration, and each one of them has a different set of requirements, right? Their heads are spinning just as much as the utilities' heads are spinning when they're trying to talk to all those different devices. So what are we trying to do at Derapi? We're addressing this basically by creating a hub, right? A universal translator where we will integrate with all of those manufacturers' cloud services. We are a cloud-first solution. All of their cloud services, and then provide, again, a universal translator to the folks on the right who are trying to build applications like VPPs to work with this. Our vision is to be able to basically connect any kind of device to any kind of service. And that actually will address multiple items on that list of imperatives that DOE identified that are needed in order for VPPs to scale and achieve commercial liftoff. We provide a full set of APIs to be able to actually do the full loop around enrolling a customer, getting permission to access their devices, reading data in order to build models or to do settlement and measurement and verification, and also control those devices as well. When I spoke with you last year, we hadn't done anything yet. We have now completed our first set of programs. This was deployed last summer, actually. This customer actually had called me about a week before I had made my talk here last year. We deployed a program with them in 8 weeks from the first call, not from contract signing, from first phone call, first conversation. And this is also lightning fast if you're thinking about utility industry. So several hundred customers, almost 3 megawatts in enrolled capacity. This program is continuing. We probably will at least double the participation in that program for this year, and we haven't really started marketing yet. So I think we're looking for a big year this year. In addition to that program, we've actually now signed a number of other customers in this space, not just in the VPP use case, but also a number of other use cases as well for people who are looking to build with distributed energy. This is all being done by just a really incredible team. I'm really blessed to be working with these folks, veterans from across the industry, Durham's companies like AutoGrid and Energy Hub, manufacturers like Proterra, Sunverge, Enphase, and then also in general tech, folks like actually even within energy, OSI Soft, DEC monitoring, and then also General Tech, Apple, IBM, NS1, and actually the New York Times. So a lot of folks who actually really understand both energy and how to build high volume, high reliability, security sensitive platforms. And what we're trying to do is build on a successful model that's been used in other industries, right? Take all of these folks who are on the top row here, all of them multi-billion-dollar companies, and bring that model here to distributed energy in order to actually unlock a wave of innovation in distributed energy, because once we take care of the software infrastructure, that frees everybody up to be able to think about how can I add value and how can I innovate in other ways. So if this is of interest to you, please feel free to reach out. Customers, partners, we are also raising a seed round as well, so investors welcome and invite you to reach out. Thanks so much.
Wonderful. Let's take maybe one or two questions.
Awesome energy and the presentation. As a founder, what are the top 2 things you consider which can make this initiative a complete failure?
One or two. I only get to choose one or two. I think the 2 biggest things. I think one is really talent. I think like most entrepreneurs, like you got to find good people, right? And either if you not able to find good people, that's really hard. Actually, if you find the wrong people and you make a mistake and you hire the wrong person, that's even worse. So that's probably number one. The other sort of big challenge for us is, we are a 2-sided marketplace, so it's a little bit of that kind of matching, right? That has to happen between a VPP provider, or a customer on one side who needs to communicate with a certain set of devices on the other.
Thanks for your presentation. My question is just around on that note you just said, for the OEMs of these devices. Yep. So do you need to roll them up one by one? And then what's incentivizing them from participating if many are trying their own VPP programs?
Yeah, so the big thing there is actually, that's why we're targeting the virtual power plant use case, because being able to connect the OEM's customer with that value stream from the VPP is actually what gets them involved, right? So yes, there are a number of manufacturers who are trying to build their own, but actually what we're seeing is that more broadly, manufacturers are actually using the VPP revenue as a sales enablement tool. So what they can do is they say, oh, you can actually earn money from your utility in this program. They roll that into the project proposal, and that actually improves the project economics for them.
Wonderful. Thank you, Thomas. Appreciate it. About a couple minutes, I want to say, we have a wonderful, wonderful founders here, and it's very hard time these days for any climate tech or clean tech companies or even VCs. They need your help, whatever the equity side help or the project side help. And today we're very glad to have the Schneider Venture Accelerator coming to really show that we provide equity, but more importantly is really the project opportunities and help this company to grow. And let me mention again, so today you heard Magnefy, which is a provide solution for asset management for any transformer, distribution and transmission. We have a Pravah, provide AI-based forecasting for demand, for climate, and for generation or anything you can forecast based on AI. We have PermitPal, be able to solve the permitted solutions, use language model for any new generation or demand technology. We have ElectricFish, be able to provide resilient EV charging solution for anywhere. And we have Axiom Cloud, provide refrigeration solution, be able to sustain a more clean and sustainable and also resilient future. We have a bus solution, be able to provide resilient solution for the whole energy infrastructure from generation to the demand and also the delivery sessions. We have Derapi, you always like to call DER API, and be able to connect any distributed energy solutions to anywhere to help any customers. With that, let's give another round of applause to all the founders. Thank you very much.